There's one last component of the periodic table that I want to discuss before we actually talk about what it is. And these are the families that occur within the periodic table. And we'll go more into this in just a couple of sections. At least visually, I'll show it to you. But many elements behave similarly because they have similar electron structures. Okay, we'll get into what's happening with the electrons next week. But there's the same electrons available to do stuff. And so we call these elements where they have the same electrons available to do stuff, we call these families of elements. And we give them names. Okay, and there are some that you might see that are not listed here. These are the most important ones to discuss. And that's the halogens, the alkali metals, and the inert or the noble gases. The halogens, and halogen just means salt former, are highly reactive nonmetals. They often combine with reactive or active metals to form salts. At ordinary temperatures, halogens exist as pairs. Okay, so the symbol is F2, but if we had a molecule, the symbol is F, but if we had a molecule, it would be F2 and Cl2. So they exist as pairs. They're sometimes called diatomic elements. And they all form similar compounds with metals: sodium fluoride, sodium chloride, sodium bromide, zinc fluoride. And notice one atom of the metal, two atoms of the halogen, one atom of the metal. Okay. And so they all form similar compounds with similar structures. Now, all these compounds are different, but the structure is the same. All the halogens will react with hydrogen to also form acid. This is where you get hydrofluoric acid, hydrochloric acid. I imagine hydrobromic acid. I don't know what that's used for. On, as you will see, the other side of the periodic table, we have the alkali metals. These are all soft metals. They're all chemically reactive. This is because they have an electron that's easy for them to lose. That makes them reactive, gives them a positive charge. Alkali metals will often combine with active nonmetals like the halogens to form very stable compounds, like sodium chloride or potassium chloride. All of them have relatively low melting points compared to the other metals that you're used to, things like iron, lead, so on. The sodium will melt when you throw it in water, essentially. That will explode if you throw it in water. But very low melting points compared to iron and lead. Finally, another family is the inert or the noble gases. They're called inert gases, I guess now. They were always called noble gases when I was in school. So you may have heard either way. These are the opposite of the other two groups. They are very inactive compared to all elements. They do not do much in chemical reactions. All of these gases can be found in the atmosphere. Argon is actually the third most abundant gas in the atmosphere after nitrogen and oxygen. Okay, nitrogen being 77% of our atmosphere or something like that. Most of what you breathe in is nitrogen, or 3/4 of it. Oxygen, something like 22%. Argon, something like 1%. Helium is much less dense than air. So any helium released in the atmosphere will just float to the top, essentially. If you put it inside of a balloon, the balloon will float upwards up to the point where the density matches the density of the atmosphere. But this is why they use helium to power things like blimps. And then these inert gases, also like neon, will light up bright colors if you pass electricity through them. So if you put the gas into a tube, in a vacuum tube, where it's just the gas, and then you pass electricity through that tube, right, you excite the electrons inside of the atoms, they glow. That is not the same as being conductive. But this is why you see neon lights all over the place. If you break the tube with the gas inside of it, the light won't work anymore. They stopped making a lot of these. Everything's LEDs now in terms of lights.